sun, and it's getting dark across parts of the UK. These live pictures from our camera point in Newcastle. At 11 minutes past the hour, the southern tip of the UK mainland will go completely dark at what is called the moment of totality. Then we'll be following the moon's shadow, or umbra, across Europe all the way into Asia, where the eclipse eventually stops just off the Indian subcontinent, actually in the Bay of Bengal.
Well, a total solar eclipse occurs when the moon passes directly in front of the sun, blocking it out completely. Now, although the sun is 400 times wider than the moon, it's also 400 times further away from the Earth. So the moon fits over the sun perfectly. And as the total eclipse approaches, the Earth goes dark and some amazing solar effects occur. Here's our science correspondent, Sue Nelson, to explain just what's going on.
The eclipse begins at the point of first contact, when the moon's disk appears to touch the sun. During the next hour or so, the moon covers the sun from the top right-hand corner. Minutes before the total eclipse, the remaining crescent of the sun shrinks to a sliver before breaking up into points of light. Called Bailey's beads, they're caused by sunlight shining through valleys on the moon. The last point of light is called the diamond ring. When this final glimmer disappears, we reach second contact, and the total eclipse has begun. For the next 2 minutes or so, the sky will be almost as dark as night, revealing a number of stars and planets. Only the sun's corona will be visible, streaming out light too faint to be seen at any other time. Third contact is when the sun begins to reappear, and the total eclipse is at an end. Daylight gradually returns until the moon eventually disappears from view at the fourth and final contact.
Now, before we talk to our correspondent Robert Hall, who's in the southwest, let's get the latest live from Newcastle. As we were saying to you earlier, Newcastle upon Tyne, to give it its proper name, is not in the line of totality. Obviously, I think it's about 70 or 80% within the line of totality. That's one of the best shots we've got from our various vantage points around the UK, indeed all over Europe. Obviously, the eclipse carries on all over Europe. Let's talk to our correspondent, Robert Hall.
Well, just looking at your pictures there, it's absolutely remarkable and such a shame that I can't see it. From here, it's been spitting and spotting with rain. It had people here, as you can see, lining the ramparts of Pendennis Castle, still hoping for a break in the cloud. We're tantalisingly hearing things from people like Liz McKean that there is a tiny break, and there was even a shot from Torbay earlier. So far, no sign here. Let's talk very quickly to Stuart Clark. Join me here, Stuart, if you would, and tell me, what are the chances now? Pretty slim. Are we even going to see the shadow here?
We should see the shadow. It's still going to look great. It's very slim chance, I think, really, of actually seeing the disk and the corona. But let's just hope it blows like crazy.
It's all moving here. I'm being told, can we take a shot of the Scilly Isles? We can see the Scilly Isles. We're told that we can. If you have a look at the monitor there, Stuart, there we go.
Wow.
There's the shot from the Scilly Isles. It's getting towards Bailey's beads, isn't it? First,
we're getting very close. Very close to second contact. Now we've only got, there you go, 6 minutes to go. We'll start seeing the diamond ring effect reasonably soon, and then shortly after that the Bailey's beads, shot perhaps even of the pink chromosphere, and then fingers crossed for prominences.
Okay, look, let's keep looking at that. It's getting, there is a sense of atmosphere here, even if we're one of the few who can actually see it. Let's hand now to Sue Nelson down on the beach with the sense experiment. Sue, any chance of a chink of light down there?
I wish. Any chance of dry weather would be nice. It's starting to rain. Umbrellas have gone up on the beach behind me, but luckily, Peter Duffett-Smith from the University of Cambridge, his computer simulation, at least that's not affected by the weather. How well is it going?
Well, it's going very well indeed. You can see now that there's more than 90% coverage. And actually, I think it is going just slightly darkish here, and that's not just because of the rain clouds.
So we're obviously at least starting to feel the effects of the eclipse now, even though it does feel like just a thunderstorm is coming.
Well, I think we are, and it's now about 10 minutes before totality, so the excitement is building.
Well, I'm glad the computer simulation is working. We've had no luck with the indirect camera projection, but we do have two students from Helston School, Louisa Tunstall and Stephen Green, and they have been doing some experiments in the run-up to the eclipse from the moment of first contact and before. Stephen, you were looking at some of the light meters not so long ago. How is it going so far?
Well, now we can definitely see it's starting to get dim. You can almost feel it. We can see that the light is definitely dimmer now than it was at the start of the eclipse. There's first contact, and here we are down here. It's definitely lower.
Temperature?
And the temperature, well, it doesn't seem to have dropped that much yet.
It does feel colder.
But it does feel slightly dimmer, yes, yeah.
Louisa, there's also an experiment going on here with a radio. Tell me about that one.
Yeah, this is actually linked up to, we're looking at how the atmosphere has changed during the eclipse. So we're hoping to get the same effect that we get at night, because at night all the radio waves are reflected off the atmosphere, and we get radio stations from all over Europe. So we've got it set on one that we could hear last night, a French radio, and hopefully during totality we should be able to hear it. We can only hear fuzz at the moment. But
and that way, of course, by knowing about the ionosphere, we're telling a little bit about the corona and how bright it is as
yeah,
well.
We learn about the sun through the...
Now, here is something slightly less technical, a candle. This is...
It's a peace prayer. There's lots of people all over the line of totality lighting candles as a prayer for peace. So we're going to be lighting our candle if we can find some matches and it's not too wet.
All right, well, it's not particularly peaceful now at the moment. It's raining, helicopters, umbrellas up, but there is still a tremendous air of expectancy and excitement here. We haven't seen a thing. We are so jealous of Newcastle. But over to Robert Hall now as we approach totality.
Okay. Sue, thank you very much indeed. We are told that we can still get rather nice pictures from the Scilly Isle, so let's have a look at that straight away. There you can see it. We are now very, very close to totality, only minutes away. And there is the moon moving across. And as it does so, we welcome our viewers from BBC World. Stuart Clark, the astronomer, is still with me here at Pendennis Point, just outside Falmouth, and here it is getting noticeably darker. The light is dropping far more than you might expect just from the heavy cloud we have overhead. That's really noted. You can feel it now, can't you, Stuart?
It's starting to feel quite eerie, quite surreal here, yes.
That was what everybody has said. It's very, very strange feeling as that light starts to go. And again, we can keep an eye on the pictures there from above the cloud bank. We're now almost down to the diamond ring, aren't we? What they call the diamond ring.
Yes.
Will we see that? There's obviously a little bit of cloud there.
Yes, well, soon they'll have to change their exposure time to get a good view of that, and you'll really see that.
As you can see that light
crescent
dropping, can't you? We're looking across the bay below us there.
Indeed.
And it's really good. Now you can feel, is that the shadow starting to come now? We can just feel, suddenly felt the light drop there.
So.
You really feel that light level dropping.
Yes, I'm
now,
looking for the shadow. It's going to come screaming towards us from over there in the west.
Will we see it even though there is thick cloud here? You'll see it coming, even with this now.
Yes, we hope so. Perhaps over the top of the clouds, where you see the bright clouds, it'll just sweep across.
We've got about 2 minutes to go, I would say, something of that order. 1.5 minutes to go, I'm being told. So, very, very close to that moment of totality. It is weird, isn't it? It's very, very odd, and the light. The character of the light seems to change as the shadow comes across.
This is what is exciting to me. There's nothing we can do. We can't stop this. This just happens. We're just here, passive observers to this whole march of kind of celestial mechanics.
I think I can sense it now. Can you feel it coming?
It's just amazing. The light is really dropping.
There's
fast.
that view again from the Hercules above the clouds. Here. You can feel now that light level is really dropping.
Can you feel
here.
how cold
I don't know whether
getting?
we can we show a shot on the platform here of just how dark it is. I can feel that shadow coming across. It's dropping right down. The light levels are dropping right down. We've got flash guns going off.
See the flashlights going in the ocean.
The light level dropping right down there. 40 seconds to totality. I don't know. Can we show a picture of Stuart and I here just to show how dark it is? Can we do that, or at least show the levels here on the platform? There we are. You can see now that it's getting as dark as it's getting, and over there, the darkness is approaching us. I don't know whether you can see it between us there. If I step back a little bit, perhaps you get a clearer view. It's dropping and dropping and dropping now, Stuart.
Yeah, the temperature is really plummeting now. We're nearly there. We're nearly there.
Look at that, and there's light behind us.
That's the best place to look, I think, for the shadow. You notice. I mean, it's
Here
just,
it goes. I can see the lights on the boats out there.
absolutely.
Look at that. We're almost to. There is the shot.
There's the diamond ring.
There's the
There's the
shot
diamond ring. We're
above the
looking
clouds.
Down about, what, 5 o'clock, perhaps? Bailey B prominence, coming something down there, perhaps?
Extraordinary.
Difficult to see.
Absolutely extraordinary. Look at that. Isn't that amazing?
Suddenly it's night. Within seconds, literally. It's gone from day to night.
Can we show a shot of the boats out there? Can we show a shot of the boats out at sea? Can we see the lights on the boats? Perhaps that'll give us an indication of just how dark it is. I don't know whether we can do that. There we are. There's the view across the sea from where we are now. You can just see that patch of light behind. Is that behind the shadow there, Stuart, that we can see? Or is that? What's that residual light we can see coming through the clouds?
It's a puzzle. Look over onto the horizon.
Yeah.
All over there. Perhaps that's outside the track of totality there. So we're just seeing some scattered light coming in, creeping in beyond the.
That cloud layer is much thinner, isn't it, beyond us? And look at that picture again. Let's have a look at that.
Indeed. So here you're seeing the atmosphere of the sun. I mean, this is hydrogen gas that's at millions of degrees centigrade. It's just streaming off into space along. You can just see the streamers of the magnetic field lines.
That is amazing, isn't it?
It's a wonderful view, wonderful.
That's the picture all these people have been dreaming of.
There's fireworks going off over there.
This is I'm giving a time to the end of totality. Now, how much have we got to go? 30 seconds to go to the end of totality. Another 30 seconds of this before it starts to lift again.
And it should become light just as quickly as it became dark for us.
That's absolutely extraordinary, isn't it? I've never seen anything like that before.
It's an amazing feeling.
And it's so quick, you could sense, I couldn't see the shadow coming across the clouds, but you could actually sense the light level dropping.
That's right.
About 10 seconds of totality, so we should, what do we see again? There's the diamond ring effect comes back up.
Diamond ring once again, as the light suddenly peeps through.
Let's keep watching that now. Just see a hint of movement. There we go, here we go, look.
There, yes.
Here it comes. There we are.
There it is.
Isn't that amazing? Look at that, and here comes the light.
Fantastic.
Here comes the light.
Just
here comes the light up here again.
Touch of the chromosphere.
And it's coming up here. Whether we can see. Can we come back to us here on the platform? There's a round of applause from the crowds behind us here. Stuart, if I just get you to step this way,
yes,
so
certainly,
we can have a look at the crowd. There was a round of applause, and you can see, even as we're watching it here, you can see the light levels coming back up. And it was a sensational thing.
Yes, absolutely.
And so quick. I had no idea it happened quite as quickly as that.
Absolutely.
Although we've been, feeling the light go. We've had to shut the exposure clearly down on the camera again. But
yes, absolutely.
And on it goes.
On it goes, off to Alderney. off to Alderney, off through France, through into Europe, and off through to the
Well, let's
Middle East.
hope those people ahead of us get a better view, because it was such a shame, because actually, from where we are standing, there might have been just a hint of that if you were out there. If you managed to sail your boat into one particular spot, you might have actually seen that. But fortunately, we did have those wonderful shots from above the clouds.
Absolutely.
And absolutely amazing pictures. The experiments, of course, that scientists would have been able to do, would they have been able to do those working from the cloud pictures?
Well, there will have been certain kinds of experiments that they could have done, some light level experiments, what have you. Anything which required direct view of the sun, they would have had to do from up in aircraft or something like that.
Stuart, for now, thank you very much indeed. And from Pendennis, back to you in the studio.
Robert, thanks very much. Let's just take a look at some of those pictures again, because obviously it's still going on as we speak. What was interesting there about the conversation that Robert Hall was having with his guest down there in Cornwall was when they were talking about the lines of magnetism which you can actually see coming off the sun. Let's take a look at some pictures coming to us from Newcastle and talk to Professor Len Culhane as we stay with these pictures. What was that conversation about lines of magnetism coming out?
Well, if you looked during totality, the gas was quite structured. You could see arches, helmet-like structures. All of this is just reflecting the magnetic field of the atmosphere. The field is strong enough to contain the high temperature gas, and so the gas just sits there and radiates at very high temperatures, but we also see some white light from it because the radiation from underneath is being scattered from these very fast-moving particles.
So you end up seeing this absolutely enormous version of the school experiment you used to do when you were 12, which was a magnet with shavings and a piece of paper. You used to shake it around and get those magnetic lines.
Yep. It's a lot more complicated, though, because the magnetic field is coming through the surface in a pretty disorganized way, and so the structure is very much more complex. But basically, it's as you say.
Let's take another look at the pictures of 2 minutes and 6 seconds of totality. This was the beginning of it. There we are. Fabulous, fabulous pictures. And what was going on when these pictures were being filmed? You could see people, you could see flashlights going off from the houses surrounding Torbay. And there was a round of applause went up from the people at Torbay as well. Now, Professor, take me through what information someone like you can get from that image.
Well, one thing one might do would be to pick a specific structure, one of the magnetic structures, and look carefully with very high frame rates in a camera, fast camera, for oscillation and intensity. And this is the key clue to waves which may pass through the gas and deposit energy and so heat it. Now, this is controversial. Not everybody agrees that this is the way in which the atmosphere is heated, but it's one very likely possibility, and people will be concentrating on that. In fact, there are UK guys at Varna in Bulgaria who have such a fast camera, which will be doing just that experiment in about an hour from now.
Because the sun is, what, 400,000 times bigger than the moon. Does the moon actually move in the orbit when it gets between planet Earth and the sun? Does the moon actually get pulled towards the sun a little bit?
Not noticeably. That would not make any real difference. It's, in fact, on occasion, when the moon is rather closer to the sun, the so-called annular eclipse appears, because then the moon isn't quite large enough to cover completely and do what we've seen today.
So that's when you get a crescent.
Yes, exactly
eclipse.
so. Called an annular. Yes.
Right, okay. Now, you were talking there about scientists in Bulgaria analysing this. What kind of information will they be able to extract this?
Well, the point I made earlier, they will be seeking for very subtle variations in individual structures to try and notice the passage of magnetic waves up these magnetic field lines, which deposit energy and may heat it. Difficult experiment, but it could well come off.
For the moment, thank you very much.
Thank you.
Now we're going to go over to the Royal Observatory in Greenwich to see what the scientists have made of all of this, and Damien Grammaticus is there. Damien.
Yes, Maxine, thank you very much. Well, I'm now in what's called, this is the Altazimuth Dome, where we get a fantastic view of what's happening with this here. This is called the photoheliograph, and with us to tell us all about it is Harry Ford. You're the planetarium lecturer here. We're almost exactly at the maximum eclipse here in London now.
We are indeed. 97% of the face of the sun covered here in the London area.
And that's what you can see here. This is just the sun just peeking out from behind
Almost disappeared. It's very difficult to see it now. But we're not getting totality as they will along the line of Devon and Cornwall. Let's hope they're getting clear skies.
Well, we hope so, but it's amazing here. It's suddenly got very cold and very dark.
That's right, and the birds are starting to twitter outside as though it was twilight and they wanted to go back to their beds.
Now, you've seen a few of these before.
Partial eclipses, yes, and they are tremendous fun. I've only seen one total eclipse, and I'm very happy to be here today for this partial eclipse. It is absolutely fantastic.
So tell us a little bit about the total eclipse that you saw.
Well, that was in 1973, and 300 astronomers from Britain actually hired a ship, sailed from Liverpool to the Canary Isles, and then to Cape Blanco off Mauritania. And there the totality was 6 minutes, more than 6 minutes. But this is just as much fun, because outside we've got the thin crescent of the sun shining down through gaps between the leaves of the trees, and you're seeing tiny little crescents of the sun on the ground. It's absolutely fantastic. I have never seen this before.
And actually, if you have another look on this projection here, it's getting a little bit dim, isn't it? Because the clouds are starting to come over
up
here.
That's right.
But you can see this little crescent of light is starting to move round, isn't it?
It's starting to swivel. And then it'll reverse itself, where it started as a tiny bite out of one side of the sun at 3 minutes past 10. it's now going to reverse the process, and there'll be a tiny little bite about 12:30 at the opposite side from where it started. And that'll be the end of the eclipse. It's clearing again. The sun's clearing from those thin clouds again.
So we've been pretty lucky here. We've had a pretty
Very
good
lucky.
view.
Yes, on way to work this morning, it was 10/10 cloud. And then gradually, as my train got closer and closer, the sky cleared. I'm absolutely astonished. We had a cloudy weather program all prepared, you see, to make sure people didn't go away disappointed, but we haven't had to use that. It's absolutely fantastic.
You must have been delighted when you saw the skies clearing here in London.
Indeed I did. I'm absolutely amazed and pleased. Yep.
And next eclipse, where are you going to see the next one?
Well, I'm not sure when the next partial eclipse is, but there's another total eclipse, 2001, but you must go across a line, Angola, Mozambique, from Atlantic Ocean to the Indian Ocean. And there are others in various parts of the world, but this is our own special eclipse.
Great. Well, Harry, thank you very much. And it has been very special here. It may just be enough to persuade people to go to Africa and see that next one. For now, back to you.
Thanks so much indeed. Now, we're just going to look at some pictures as the eclipse has passed through and is going into northern France. I think we can just see them coming up here. There we go. Very good pictures here. It's going across to Reims in northern France. Now, it's in Reims in northern France. Of course, there's been a lot of
sun, and it's getting dark across parts of the UK. These live pictures from our camera point in Newcastle.